The most annoying problems to troubleshoot are those that you can't reproduce consistently. Bad parameter sniffing often results in very inconsistent behavior, erratic behavior where performance is sometimes fast, sometimes slow, and that makes this a very difficult problem to troubleshoot. In this video I'm going to talk about bad parameter sniffing, explain what it is, and explain what you can do about it. So often I hear people talk about parameter sniffing as if it is a problem, and you will have noticed I'm talking about bad parameter sniffing in this video, because in itself parameter sniffing is not bad. Parameter sniffing is good. Imagine that I submit this query. Now, if I ask you to assess how many rows this will return, which is of course important to create an optimal execution plan, then you are going to ask me what is approximately the cutoff date. Because if you don't know that, how are you going to predict the number of rows? And that is exactly the problem that SQL Server has when the cutoff date is an unknown variable. It has to create an execution plan for this query, but cutoff date might be last week, it might be somewhere in 2005. This query might return just a few rows, or hundreds of thousands, or even millions of rows. And yet, without knowing the cutoff date, SQL Server has to create an execution plan that is optimized for an assumed number of rows. And in cases like this with inequality, SQL Server simply assumes that 30% of all sales orders will qualify, which might be true if cutoff date is 3 years ago and you have 10 years of sales history. But if cutoff date is last week, it's not true. If cutoff date is 3 years ago and the system is 3 years old, you get almost all the rows, and again that 30% is incorrect. So because SQL Server doesn't know the value of cutoff date, it has to use an assumption. It just uses 30% and we go with it. And we get an execution plan that is probably not optimal. So how much better would it be if SQL Server knows what the value of cutoff date is? If SQL Server knows that cutoff date is start of this week, it will create an execution plan that is optimized for a relatively low number of rows, and that will return the results very fast for that number of rows. Whereas if cutoff date is 10 years ago, we will get a different execution plan that is optimized for returning almost all sales. If SQL Server knows the cutoff date, it can give us better execution plans based on the statistics it has on the order date column, and those are much closer to reality, and we get a better execution plan. Now, when does SQL Server know the cutoff date? When the cutoff date is passed in as a parameter into a store procedure, user-defined function, or parameterized SQL. In all those cases, because cutoff date is passed in as a parameter, SQL Server can sniff it, look at the value you passed in, and then create an execution plan that is optimal for that value, giving you much better performance. So overall, parameter sniffing is a good feature that gives us better performance. Now, to understand bad parameter sniffing, I need to talk about a different feature first: plan caching. You have to understand, creating an execution plan is expensive. We need to check everything, we need to work out what is said and convert it into a different format, check all the statistics, then go through all the different variations that might be possible to find the cheapest execution plan. That is a lot of work. It takes a lot of CPU time and also elapsed time. So if you think about your production server, it is constantly running queries. If you have to compile that query every time, that is a lot of CPU to burn, and On most production servers, we are often running the same query over and over again, because that is a production workload. We are simply doing the same work. People are looking up the details of a contract. It may be a different contract, but it's still the same query every time. So that's where the plan cache comes in, also called the procedure cache. I like the term plan cache better because it caches all execution plans. Whenever a query is compiled, we store that query plus the execution plan in the plan cache, so that if the same query is then executed again, we don't have to repeat that expensive compilation of the query. We can simply reuse the execution plan. And especially on production servers, this saves a lot of expensive compilations, which means that you have way more CPU available to run your queries instead of compiling the same query over and over and over again. Now, of course, a plan cache reusing all plans means that we need to have some things in place to invalidate or evict old plans. For instance, when you create or drop an index, you might want to recompile the execution plan that is based on that index. When statistics are updated, you might want to check whether with the new statistics a different execution plan is now cheaper. And when there is memory pressure, SQL Server will also evict execution plans that haven't been used in a while, which means that later we have to recompile it, simply because we want to use that memory for other things. So there's different reasons why those plans get evicted, and all of this is a great feature that helps reduce compilation time. So we have two good features: parameter sniffing and plan caching. And then bad parameter sniffing sometimes happens when these two good features start to interact in an unwanted way. So what happens then is SQL Server runs a query. The query is not in the plan cache, so it has to compile that query. And it has parameters, so in order to give us the best possible performance, it sniffs the parameters, compiles the execution plan, and then stores that execution plan in the plan cache so that it can reuse it later. But later might use different parameters. That does not invalidate the execution plan. So even though the parameters now have different values, the plan that was optimized for the originally sniffed parameters is reused. Often that doesn't matter. In most cases it doesn't. But there are a few cases where this interaction can result in erratic bad performance. And the most common situations, there are three of them. I'm going to talk about each of them. One of them is when you have a filter, an equality predicate on a column that has a very skewed data distribution. For instance, where city equals at city. Now this doesn't need to be skewed, but it can be. It depends on what your database is. If you are working in the subscriber database for the Boston Daily, then probably 99% of your subscribers live in Boston. And the remaining 1% live all across the USA and even outside of the USA in many different cities. So for city Boston, you would get 99% of all rows. For every other city, it would be less than 1%, perhaps just 1/100%. And that means that for city Boston, you want a very different execution plan than for instance, the city Knoxville. But if the execution plan for Knoxville is stored in the procedure cache and then reused when you call it with Boston, you might get bad performance. Another example is where gender equals at gender. Now, let's say that in your database, 48% of all persons are male, another 48% are female, 3% have not have their gender not applicable because they are not natural persons but legal persons, companies, and 1% have specified their gender as other. An execution plan that is compiled for the sniffed value other will be very fast for other, but when that is reused for male, it will not be fast because it is optimized for a very different number of rows than is estimated when the execution plan was created. So it's not just the equality, it's the combination of equality and a skewed data distribution. If you had a more old-fashioned system that only has gender male and female, both have 50%, then you would not get any bad parameter sniffing on where gender equals at gender. If your people database, people table has all the cities roughly equally represented, somewhere between 0.3 and 1.5%, those differences are small enough that where city equals at city would not hurt you. The skewed data distribution is what causes problems. Then another class of problems that can result in bad parameter sniffing are inequality predicate with very varying selectivity. We already saw the example where order date is larger than at cutoff date. If we don't sniff this parameter, then we get 30%, which sometimes might be good enough, but often will be much slower than needed. If we sniff this, we get a better execution plan. But what if sometimes the cutoff date is last week and sometimes it's 5 years ago? At one point, for reasons we can't really predict, so it becomes a semi-random and unpredictable process, the execution plan gets evicted from the plan cache, so the first time the query runs again, we sniff the value and we create an execution plan for that value. And if that is last week, then from then on, all queries that have a recent cutoff date will be fast, but queries that have a cutoff date long ago will be slow. And then at another time, the execution plan is evicted from plan cache again, and now the first execution happens to be 5 years ago. Now we get a cached plan that is optimized for 5 years ago, which means that everyone who asks for a range of 5 years ago, 7 years ago, 4 years ago, all those will have good behavior, will be reasonably fast. But now the people who ask for all sales since the start of this month will run into slow problems. And that is this erratic behavior, because they will create a ticket and by the time you open the ticket and look at it, the plan has been evicted from cache again, a new plan has been compiled, and their bad behavior doesn't reproduce. That is what you always see with bad parameter sniffing. The third common root cause for bad parameter sniffing is when you have optional parameters. Code in your query that looks like this, where parameter is null or column equals parameter. So either you pass in the sales order ID and then you only select the rows that have the sales order ID you passed in, or you leave sales order ID null, empty, and then all rows will be matched. Now this hardly ever exists on its own. When you have queries like this, it's often multiple such optional parameters, and this happens in store procedures that have 3, 4, 5, 8, 10, whatever number of parameters. All of them are optional. The user can specify whatever data they have. They leave blank the data they don't have, and their selection shows them a selection based on what they passed in. It's very common, but this is also very vulnerable to bad parameter sniffing. Imagine there is no plan in the plan cache. I execute this query for the first time and I pass in customer ID and salesperson ID, but not the sales order ID. SQL Server will now create an execution plan that is optimized for selecting on customer ID and salesperson ID. So it might start with an index on customer ID or on salesperson ID. Perhaps there's even an index on both. Anyway, it will start with an index seek, and then it will also do an additional test on sales order ID, because even though sales order ID is null in this execution, SQL Server knows that the execution plan may be reused, and it will create an execution plan that will always return the correct results. But it's optimized for customer ID and salesperson ID passed in. So let's say that it starts with an index seek on customer ID. Now, if the next execution passes in only the sales order ID, it will reuse that execution plan. So it will start with an index seek on customer ID. That returns everything because customer ID is null and we still have all the rows. And then it might go into a key lookup into an index seek to filter further on sales order ID, and that will run hundreds of thousands of times, and the query is slow. And again, by the time I look at the ticket, a different execution plan will be in cache and it might not reproduce. So this is once more an example of bad parameter sniffing. 3 common root causes: equality on a skewed column, inequality with varying selectivity, and optional parameters. Those are the 3 main situations where you can run into bad parameter sniffing. You don't need to, but you might. And that, as said, results in this erratic query performance. Sometimes the query is fast, sometimes it's slow, and you really can't reliably reproduce this. And it changes at seemingly random moments, because can you predict when there is memory pressure and the plan will be evicted? Things like adding a column or dropping an index, those are things you know. But memory pressure, it's impossible to predict. And even automatic updates of statistics can sometimes happen at unpredictable moments, and that might result in a new plan being created in the cache, and all of a sudden queries that were slow become fast and queries that were fast become slow. Now, if you have the query store, then troubleshooting becomes a whole lot easier. Here you see an example of a query that uses this erratic behavior, and you see that in this case there are 2 execution plans, number 3 and number 4. They are different execution plans for the same query. And you also see that neither is consistently faster than the others. And this, what you see on the screen, is even a bit misleading, because this bubble here, it might seem that you have 150 milliseconds, but in reality these were various executions varying from 6.9 milliseconds to over 60 milliseconds. And this yellow one, which is for plan 3, which seems to be more expensive, actually had some some faster executions, and some much slower as well. So the performance is all up and down, and both of the execution plans is sometimes fast, sometimes slow. In this case it's just 2 execution plans. It might be 2, it might be 5, it might be 20. But common for bad parameter sniffing is that each of those execution plans is sometimes fast, sometimes good. None of them is consistently good. Another thing you will see if there is bad parameter sniffing is that if you look at the properties of the select, you will see a property parameter list. In this case there is 1 parameter, and you can see that this execution plan was compiled for the city Racine, whereas the other execution plan is compiled for the city London. And you can already imagine that London probably has way more rows than a rather small city like Racine. So this is how you can see in the query store that something bad is happening. You see this up and down performance, and you see multiple execution plans that have a different parameter compile time. You can then also run the query yourself. Now this query is part of a stored procedure, so if I execute that stored procedure for both London and Racine, I get my results and I can look in the execution plan, and in this case the execution plan that was executed was compiled for London and executed for London. So this execution will be fairly fast, but the second execution reuses the same execution plan that was compiled for London, but the parameter compile time runtime value is now Racine, and you see that in this case there will be some serious bad estimates here because the data is optimized for London, reality is Racine, and you see those bad estimates that result in bad behavior and bad performance. So now we know what bad parameter sniffing is. We've seen how hard it can be to troubleshoot and how the query store might help. Let's see what we can do about it. And one option is to force SQL Server to always use the same execution plan. That gives us predictable performance. Not necessarily good performance, predictable. And whereas I personally prefer to always have good performance, businesses tend to prefer predictable lower performance over performance that is sometimes very fast and sometimes very slow. Of course, in the demo all the execution times were in milliseconds, but that's on AdventureWorks, which is a very small database. Imagine a query that sometimes finishes in 20 milliseconds and sometimes takes 5 minutes, and you never know in advance which it will be. Most users will prefer to have that replaced with a query that always finishes in, for instance, 20 seconds. It might not be optimal, but they know what they can expect. Now, if you want to use this method, the query store makes this easy. So let's return to the demo. Let's return to the query store. And in this case, like I said, there are two options, and neither is always good and is always fast. But let's say that you determine that plan 4 is the one that is always fast enough. It might not be fast, but it's fast enough. So you determine that plan 4, make sure it's selected, is the one that you want to force always. I can click force plan. I say yes, I want to force this plan, and the workload is still running. When we return to this query store in a few minutes, you will see that from now on plan 3 will not be used. It will always be plan 4. And now the performance has become predictable. Perhaps not good, but good enough and predictable. And you saw how easy this is. Without the query store, this is a lot harder. Now you will have to use the use plan hint, which is a very cumbersome hint because you need to include the entire execution plan as XML in the hint. And if you can't use the query, you can't change the query because it's the third-party code, then you will have to create a plan guide to attach that use plan hint to the query, and all that is way beyond the scope of this video. You can do it if you really must, but it's difficult. Anyway, regardless of how you do it, whether you do it through the query store or whether you do it the hard way, I think that forcing an execution plan should be a temporary fix. Okay, we have identified that this query has bad parameter sniffing. Let's force it to an execution plan that has good enough behavior. And then accept that good enough behavior until we have the time to look further into it and see whether we can create a permanent fix. So what other ways do we have? One way that not everybody likes is to use option recompile. This is a hint that you can add at the end of the query. Please do not do this for all queries. But if you have identified one query that causes issues with bad parameter sniffing, then option recompile can be a fast, quick and easy way to fix it. What this does is it tells SQL Server, I know that you have a plan cache. I know that you like to store and reuse the execution plan. You can't. Not for this query. This query will never go to the plan cache. That gives us an upside. You always get the best possible performance. You never run a query for a city racing with an execution plan that was optimized for London, because you get a new execution plan that will sniff the city and it will give you the execution plan that is optimized for racing when you run it for racing. And then when you run it again for London, you get a new compilation and you get an execution plan that is optimized for London. In some cases, option recompile might even give you a faster plan than a sniffed plan, and that is especially the case with optional parameters. The reason here is that SQL Server knows that the plan will not be reused. So if you execute the query with sales order ID is null, SQL Server knows this execution plan does not filter on null, and it won't be reused. So whereas with a sniffed plan it would optimize for null but still include that filter because the query can be reused, if option recompile is used, you get an execution plan that doesn't even include the filter at all. And in some cases, like I said, that might be even faster. So this looks like a great option, right? But there is one very big problem, and that is the price. Now, if this is a query that runs 10 times per day, then this high price of a full recompile for every execution is 10 recompilations per day. Unless it's a very expensive complex query that joins 20 tables and that takes 2 minutes to compile, those 10 compilations don't matter. But if you do this on a query that executes 1,000 times per minute on your production server, then you now get 1,000 compilations per minute. If one such compilation takes 50 milliseconds, that's 50,000 milliseconds of CPU time per minute. That means that multiple of your cores are constantly only doing compilations and are not having any cycles to spare to execute the query. That is a way too high overhead. So somewhere in between those extremes is a point where I would say, and I can't really tell you where that is because it depends on how many executions you have per day, how expensive a compilation is, and how much power you have in your server. But there is always a point where the compilation overhead becomes too much and option recompile is not a good idea anymore. This is also the reason why some people say don't use option recompile, just to be on the safe side. I think you are smart enough to determine yourself whether a query can use option recompile or not based on how often it runs and how expensive those recompilations are. If the recompilations are cheap enough, then option recompile is, in my opinion, a very easy, simple and fast way to solve the problems caused by bad parameter sniffing in a specific query. But it's not always possible, and that's where the rest of the options come in. Another option is to use the optimize for hint, and when you use this hint you can specify always optimize this for a specific value. So instead of sniffing the city, you might say optimize for New York. Or you could say optimize for unknown, which means that SQL Server doesn't sniff the value and considers it as if it were an unknown variable. So you just lose the benefit of parameter sniffing, but also the downside of this bad parameter sniffing interaction. And that sometimes works. For the Boston Express, perhaps an execution plan based on, hey, we have 10,000 cities in the database, so let's estimate that every city has 0.01%. Perhaps that execution plan is good enough for all cases, even for Boston. If you have those four genders with the distribution 48%, 48%, 1%, 3%, if you don't sniff it, SQL Server will say, oh, there's four genders. I don't know what gender you pass in, so I'm going to estimate 1/4, 25%. That is always wrong. And perhaps you now get an execution plan that is bad in all cases. Then optimize for unknown doesn't help you. But perhaps that execution plan that always based on 20, that is always based on 25%, perhaps that execution plan is good enough for all those four cases, even though the estimates are always off. So you can use optimize for unknown, or you can optimize for a specific value. The challenge here is to find a value that is good enough in all cases. That is the hard part. The easy part is then putting in the hint. Especially when you have equality on skewed data, optimize for might be a good solution. For optional parameters, it does nothing. Hardly ever. Sometimes perhaps, but hardly. For inequality, it's also very hard to find a value that is always good enough. But for skewed data, sometimes this is a good solution. However, you need to document it and you need to maintain this going forward. Imagine putting in a hint that says optimize for cutoff date is, and then you put in the date January 1st, 2026, because you know that that value always gives you good performance. Now, but what if someone looks at that code in 2029 and sees that it still optimizes for 2026? Is that still optimal performance? Hardly ever. And you may be laughing right now, but I actually encountered such a hint once at a client site where one day they had put in a hint and then 3 years later that hint still optimized for the same date. So this is something you absolutely have to regularly check. The optimize for hint might be a good one, but it is one that requires constant verification and maintenance. Then I have seen people use this option. Yeah, there are parameters in the store procedure. We copy them to a local variable and then we use the local variable in the query. That has basically the same effect as optimize for unknown. So why would you use this ever? Well, because before SQL Server 2005 we didn't have optimize for unknown. That was introduced only 21 years ago. And yes, there are still websites that recommend copying a parameter to a local variable. There are still companies that have coding standards that say that all parameters in all store procedures needs to be copied to local variables and only the local variables can be used. So they don't even disable parameter sniffing for queries where we have this bad interaction. They disable parameter sniffing across the board and you lose all the benefits. Please don't use this. Absolutely don't. If you use this, you are telling me I have not updated my SQL Server knowledge since 2005. Not really what you want to tell me. I am going to mock you. Don't use this. Something you can do is split the procedure into multiple separate procedures. And this can be very useful when you know the outlier values. Let's return to the Boston Express. We know that 99% of our customers are in Boston. We know that the remaining 1% are scattered across 1,000 different cities. We know that Boston is the one value that requires a different execution plan from the rest. So we have this procedure get orders by city, and instead of doing the query here, I create two new store procedures. Get orders by city Boston and get orders by city other. And the original store procedure get orders by city. This store procedure still sniffs city. This store procedure might still have an execution plan that's optimized for Boston when you run it with Racine. I don't care, because this store procedure only checks the city and then calls another store procedure. Get orders by city Boston will be optimized for Boston. Get orders by city other will be optimized for, well, I don't know which city, but I know that it is a city with a relatively low number of subscribers. And what if Boston is not your only outlier? What if there's a few large cities that need a different execution plan? Well, then you can just put those in the code. And again, this might require maintenance across the line. 2 years from now, different cities might be needed here. And sometimes those outlier values are not known. But you can use this with skewed data. You can also use this with inequality. Just have one store procedure for everything that is less than a year and another store procedure for more than a year. You can have even 3 store procedures with different ranges. You can use this when you have optional parameters, but there it can become unmanageable. If you have just one optional parameter, then you need 2 store procedures. If you have 3 optional parameters, then you have 8 different combinations of which can be supplied or not, so you would need 8 store procedures. If you have 10 optional parameters and you want all the combinations, you need 1024 store procedures that basically are all copies of the same query for different parameter combinations. And now imagine what happens when one column needs to be added to the report. Now you need to change all 1024 store procedures. This becomes completely unmanageable. So it works for optional parameters, but with this management problem. And that is where I would typically advise, try to identify which parameter combinations are used more often. In practice, even when you have those hundreds or thousands of different combinations, in practice you see that often there is like 5 or 10 or 15 combinations that are used the most often. Create store procedures for those most common cases so that they always perform fast, because they are always optimized for the store procedures, for the parameters that are actually passed in. And all those hundreds of other options that are rarely used, just accept that there you might have bad parameter sniffing. Tell the users, yes, you can give every combination of values in these search fields, but if you use something that is not common, it might be slow. That is also a kind of predictable performance. And sometimes it is not slow, well, bonus, but you can just put it, you could even put it on the screen. If you search for these combinations, this might be slow. Do you want to continue? So that is a good way to get a trade-off, to have a limited number of store procedures that you can still maintain, so that you get good performance in those cases and accept the bad performance in the rare cases where someone needs to search for an uncommon combination. And then yet another procedure, another possible solution is to use dynamic SQL. This is basically only useful for the optional parameter option. If you have skewed data or inequality, dynamic SQL is very unlikely to help you, but with optional parameters it can be useful. But when you use this option of dynamic SQL, you have to be very careful. You have to avoid any risk of SQL injection. My previous video was about this specific issue, and that was for a reason, that was to prepare for this video. I want you all to be aware how dangerous SQL injection is and how easy it is to avoid. So if you haven't yet, go watch my previous video, and then you will see that if you build your dynamic SQL like this, no user input goes into the query. Everything that goes into the query is red. There is nothing black going into the query. So this is safe. And now you can use SP execute SQL to use this as a parameterized call to a dynamic query that only includes the filters that you need. So again, if you have 10 different optional parameters, you might get 1024 different execution plans, but you don't have to build all those 1024. They are built by the dynamic SQL. They do go into the plan cache, but they will be evicted if not reused, and those that are reused, are used often enough, will remain in the plan cache. So this is a good way to work around the problems with those optional parameters if you avoid the risk of SQL injection. I'm going to repeat this, and I'm going to repeat this very slowly. Avoid SQL injection. Only put red text in the query string. You can also use combinations. For instance, you might say, okay, I have a few separate procedures that I use for the most common cases. And then for the less common cases, I use option recompile, which I can do because they are less common. They are only used a few times per day, so I can put the option recompile on there. But the options that execute hundreds or thousands times per minute, those have their own separate procedures that are not recompiled every time but optimized. You might use optimize for in some cases, dynamic SQL in other cases, so you can mix and match all these things. And all across this talk I have assumed that you can't change your indexes and you can't change your code. Of course, if you can change the code or if you can change the indexes, especially if you can change the indexes, you might be able to come up with an indexing strategy that, regardless of the parameters, always gives you good performance. But that is not always possible, especially when you optimize for third-party products. If you can't change the indexes, then you can perhaps use any of these options. And of course, if you can't change the code, then you're also limited. You can't use separate procedures if you can't change the code. You can't use dynamic SQL in that case. But option recompile, optimize for, enforcing an execution plan, those are still available through plan guides, even if you can't change the code. Now, if you are on SQL Server 2022, or on SQL Server 2025, then there are two new features, one in SQL Server 2022, two in 2025, that Microsoft created to help fix bad parameter sniffing. I will talk about those in the next videos. This video was about what bad parameter sniffing is, how to identify it, and how to fix it without those new features. All the tips I've given here apply to all versions of SQL Server, even 2022 and 2025, because the new features do not disable all the old methods. That was the video. I hope you learned something. If you liked it, click like. Perhaps you might click subscribe. If you have a question, leave a comment. If I see it, I will try to answer. I thank you for watching. My name is Hugo Cornelis. Until the next time. Bye bye.